Now it's our time to enter into the most important aspects of mechanics, that is laws of motion. Newton's laws of motion, in which the second law defines the force as the rate of change of linear momentum with respect to time. So now we are moving towards the last part of the mechanical flowchart, in which the linear momentum and the time change is connected. You can say that I've taken the time change along this line. It is not touching this line, so it is coming and it is joining with the momentum. So the force acting on an object is defined as the rate of change of momentum, that is dp divided by dt. This is the law which we learn as Newton's law of motion, the second law of motion. And as well, we can derive a simple relation when the mass is constant. I'm connecting the mass with the acceleration. The acceleration and the mass is connected, and that is also giving you force. So the force is defined in our mechanical flow chart, and the force is also a vector quantity. SI unit of force is kilogram meter per second square, and the dimensional formula is ml t raised to minus 2. Now you can see that the mechanical flow chart, it's a simple aspect or the simple idea, so that you can connect all the quantities and you can learn all the relationships in a single glance. So whatever we have seen here is a flow chart that will help you to learn the different units in simple manner. We can say that position, time change, displacement, velocity and acceleration. These are the aspects which we require in order to learn motion along a straight line as well as motion in a plane. What I mean is, in order to learn one-dimensional motion and two-dimensional motion, we need only this much aspects. Now when you are connecting the linear momentum, or when you are learning linear momentum and force, we can say that the next unit, that is Newton's laws of motion, is also under our control. Now we are in the stage of concluding the points which we have learned. We have seen that the units of one dimension, two dimension and Newton's laws of motion can be learned like this. I have drawn 3 eggs from this. I'll treat them as the products which I have got from this discussion, and all the 3 products will be very familiar to all. They are, the first one is the work done, the second is energy, and third is power. So the work done, we will represent it as capital W. That is nothing but it's the product of force and displacement. Force and displacement. F dot S. The details we will learn when we are discussing the unit work, energy and power. From this I can say it's a scalar. Unit is kilogram meter square per second square, and the dimension is ml square t raised to minus 2. And the energy, it can be represented with E. It's nothing but it's amount of work done. We will define it in 2 terms or 2 ways two modes. One is of the form of kinetic energy, and the other one in the form of potential energy. And the power delivered is the work done per unit time or energy consumed per unit time. We can take it as energy per unit time, E by T, or we may also write it as F dot S divided by T, or S by T, displacement divided by time. What is displacement divided by time? That is velocity. And so we can also express that one in the form of force into velocity, or force dot velocity. This is also a scalar quantity, has got a unit of kilogram meter square per second cube. Hence the dimensions can be written as ml square t to the power minus 3. So this is called as a mechanical flow chart, or a flow chart which will be helpful for you to learn mechanics of all the particles.